For the for the screencast of chapter 15, I have reworked on the video above. Here you can see there is a sphere of radius r with a negative charge negative q, which is located at a distance r from a wire which is of length l equals 4 millimeter. So the problem says to find the force that the ball exerts on wire. So since this ball is negatively charged, it makes a field that polarizes the wire, as you can see in the figure. This polarized wire will also make a field that polarizes the ball, but let's assume in this problem that the effect is so small that we can neglect it, so that we can consider this ball to be as a point charge. This polarized wire will be attracted by the ball, and this ball will be attracted by the polarized wire. So we can write this that the field on ball equals the F on wire, which is the reciprocity of the electric force. We can further write this F on wire by Q ball and the field electric field by the wire. And if we consider this wire as dipole with charge plus and negative q at the end, we can use the formula, which is 1 by 4 pi epsilon naught 2 ql r cube. Now we also need to know that the net electric field inside the metal wire, which is the sum of applied field and field due to the charge buildup on the edge of wire, goes to 0 in equilibrium. So we can consider that E net equals 0 in equilibrium. This can also be like further demonstrated by this figure, where you can see the E ball cancelled by the E wire. So now we can further use the dipole formula in getting the E net. X equals E ball x plus E plus end of the wire and E negative end of the wire. We know that this electric net field equals 0, and electric net field at ball at x equal be 1 by 4 pi epsilon naught q r square. At the positive end it will be 1 by 4 epsilon naught q l by 2 r square, and the negative end it will be 1 by 4 epsilon naught q l by 2 whole square. So now if we do the calculation, we get the q, the charge on the electric field, to be q, the charge of ball, upon 8 l by r whole square. So at the location outside the wire, we can model the wire as dipole. So the force on the ball, which is also equal to the magnitude of the force on wire, we can write that as force equals q 1 upon 4 pi epsilon naught 2 q l r cube, and we know the value of q that we got earlier, which is q by 8 l by r whole square. If we substitute that value on here, we will get the force to be 1 by 4 epsilon naught q square l cube 4 r to the power 5. So now if we just substitute the numerical value that we have been given earlier, we get a value of 1.4 into 10 to the power minus 11 Newton. The thing to consider is that we need to be carefully about the units. Here you can see the units of the length of wire is 4 millimeter and the distance is 10 centimeters, so we need to be careful about the units. So if we do it correctly, then the value, the force ball exerts on the wire, comes out to be 1.4 into 10 to the power negative 11 Newton.